In today's lecture, we're going to talk about hypothesis testing. What is an hypothesis? A hypothesis is an educated guess regarding what should happen in a particular situation under certain conditions. A hypothesis test is a process that uses sample statistics to test a claim about the value of a population parameter. That population parameter can be the average, can be the proportion, can be the variance. So we're going to discuss each one of these in this class. Researchers in fields such as medicine, psychology, and business rely on hypothesis testing to make informed decisions about new medicines, treatments, and marketing strategies. So hypothesis testing in general are very important. How do we state a hypothesis? From informal to formal statements. A statement about a population parameter is called a statistical hypothesis. To test the population parameter, you should carefully state a pair of hypotheses. One that represents the claim and the other one which is the component. Another component is the complement or opposite of it. When one of these hypotheses is false, the other must be true. Either hypothesis, the null hypothesis, or the alternative hypothesis may represent the original claim. So when you read an example, when you read a question, you have a hypothesis. That hypothesis might be null hypothesis, it might be alternative hypothesis. That might be a claim or not. Our goal is to identify the claim in the hypothesis testing. What is a null hypothesis? A null hypothesis, or H sub 0, is a statistical hypothesis that contains a statement of equality, such as less than or equal to, more than or equal to. The alternative hypothesis, H sub A, is the complement of the null hypothesis. It's a statement that must be true if null is false, and it contains a statement of strict inequality, like more than, not equal to, or less than. The symbol H0 is read as H sub 0 or H naught, and HA is read as H sub A. If you open different statistics book, you might see H sub 1 instead of HA as well. So these two are equivalent statements representing the alternative hypothesis. In general, when you read news or example or working on your homework, you have a mathematical statement to work with. What is a keyword or verbal statement that represents null? What is a verbal statement that represents alternative hypothesis? And how do we confirm that it's actually null, it's actually alternative hypothesis in this case? And how do you write this mathematically? If you have a keyword like greater than or equal to, at least, not less than, it means that your null hypothesis is given. In this case, we write down the null hypothesis saying that mean of the population, or the mu, is more than or equals to k. When you read news or homework or any question, including one of these keywords, less than, below, fewer than, it means that your alternative hypothesis is given. The alternative hypothesis in this case says, hey, the population mean is fewer than k. The population mean is less than k. The population mean is below k. This is your very first category analyzing null and alternative hypothesis. The next set is basically keyword that says less than or equal to, at most, not more than. This is basically your null hypothesis. Mean is less than equals to k. The population mean is less than or equals to k. The population mean is at most k. The population mean is not more than k. But when you see a keyword like this, greater than, above, more than, it means that the alternative hypothesis is given to you. So in this case, population mean is greater than k. Population mean is above k. Population mean is more than k. So different ways representing the alternative hypothesis. So far, we have two categories. The first category, the second category. Now let us take a look at the third category. In the third category, one of these keywords is given to you. Equal to k. K. Exactly k. If you see these keywords in the question, it means that the null is given to you. Null hypothesis in this case says, hey, population mean equals to k. Population mean is k. Population mean is exactly k. Now, if you see these keywords, not equal to, different from, not, it means that the alternative hypothesis is given in this question. Alternative hypothesis says the population mean is not equal to k. Population mean is different from k. Population mean is not k. So this is your third category. When it comes to hypothesis testing for one sample or for one population with one sample, these are all the categories that you can classify your null and alternative hypothesis. Let's take a look at a few examples. This is the summary of what we saw. In this question, we want to write the claim as a mathematical statement. Question says, state the null and alternative hypothesis here. So the question says, a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. Usually a student makes this mistake that's saying that, hey, at least is the keyword. Unfortunately, at least is not a keyword here. Why is that? Because the claim, the proportion is 61% gives you the keyword. This can be written as the population proportion is 61%. Its complement is P is not 61%. It might be less than 61%, or it might be more than 61%. Because P is equal to 61%, contains the statement of equality, it becomes the null hypothesis for you. Again, pay attention to the keyword is 61%. The keyword is in the third category. So you can basically write the null and alternative hypothesis. But please note that here in the summary, we just focus on the mean, but here we are working with the population proportion. We just need to rewrite this using P instead of mu. Take a look. Null hypothesis says, hey, the proportion is 61%, and this is your claim. Alternative says, hey, the proportion is not 61%. We can visualize this as well. Null hypothesis, which is located exactly at 61%, says the proportion is 61%. The alternative hypothesis says it's not 61%. It's either less than 61% or it's more than 61%. After we state the null and alternative hypothesis, we have to run some tests. So here's a summary for you. Now, let us take a look at this question. A car dealership announces that the mean time for an oil change is less than 15 minutes. Less than, fewer than. The claim, the mean is less than 15 minutes can be written as mu is less than 15. Its complement is mu is more than or equals to 15. Because mu or mean is more than equals to 15, it contains the statement of equality. So what's the meaning of that? It means that the null hypothesis is given to you. In this case, the alternative hypothesis is representing the claim. So the null hypothesis can be written as mean is more than equals to 15 minutes. Alternative says, hey, not so much. The average is less than 15 minutes, and this is the claim of this car dealership. Another question for you. Again, try to remember this summary. Question 3 is company advertises that, claims that, so the keyword, the mean life of its furnaces is more than 18 years. More than 18 years. The claim, the mean is more than 18 years, can be written as mu more than 18. Its complement, which is mu is less than equals to 18, which is your null hypothesis. The complement is null hypothesis because mu is less than equals to 18 contains the statement of equality. It becomes the null hypothesis. In this case, the alternative hypothesis represents the claim. We can write it this way. Null hypothesis says, hey, the average is at most 18 years. The claim of the company is the average is more than 18 years. So in this case, your claim and alternative hypothesis are the same thing. We defined null and alternative hypotheses, and we categorize them into 3 categories. What is a level of significance? In a hypothesis test, the level of significance is your maximum allowable probability of making a type 1 error. It's denoted by alpha. The probability of making a type 2 error is denoted by beta. Recall what is type 1 and type 2 error. A type 1 error happens if the null hypothesis is rejected when it is true. A type 2 error happens if the null hypothesis is not rejected when it's false. Take a look at this table that is summarized everything nicely here for you. The truthness of null hypothesis and the decision. If the null hypothesis is true and you do not reject the null hypothesis, this is a correct decision. However, if null hypothesis is false and you don't reject it, this is called type 2 error. If the null hypothesis is true, but you reject the null hypothesis, we call it the type 1 error. If the null hypothesis is false and you reject the null hypothesis, it is a correct decision. So that's how you can summarize type 1 error and type 2 error using this nice table. But again, our goal is to define the level of significance. In a hypothesis test, the level of significance is your maximum allowable probability of making a type 1 error. It's denoted by Greek letter alpha. Our next definition is p-value. If null hypothesis is true, then a p-value or probability value of a hypothesis test is the probability of obtaining a sample statistic with a value as extreme or more extreme than the one that you got from the sample data. We're going to use p-value to make a decision about hypothesis test. If the p-value or the probability value of a hypothesis test, which is obtained from a sample statistic with a value as extreme or more extreme than the one that you got from the sample data, is less than equals to alpha, then you reject the null hypothesis. If p-value is more than alpha, then you fail to reject the null hypothesis or you support the null hypothesis. So let us take a look at the tail of the hypothesis testing. Then eventually we're going to define p-value using the left tail, right tail, or two-tail hypothesis. If the alternative hypothesis, HA, or again, guys, if you open different statistics books, H sub 1 contains the less than inequality symbol, less than, then the hypothesis test is called a left tail test. Why it is important for us? Because we can identify and locate the p-value. The p-value is on the left tail of the graph, and p-value is the probability or the area below the curve on the left side of standardized test statistic. But again, please pay attention. If the alternative hypothesis, H sub 1 or H sub A, contains less than, it means that you have a left tail test. The p-value, which is the area to the left of standardized test statistic, is located on the left-hand side, and we call it a left tail test. We also have a right tail test. If the alternative hypothesis, HA or H1, contains the greater than inequality symbol, more than, then the hypothesis test is called right tail test. So now your alternative hypothesis includes more than, and the p-value lands on the right-hand side of the graph. P-value is the area to the right of the standardized test statistic. You calculate the standardized test statistic or z-value, and you find the area to the right-hand side of it, and this is your p-value. Then you can make a decision comparing p-value and alpha. Again, this is called right-tailed test. We also have a two-tailed test. If the alternative hypothesis, HA, or another way that we represent this, H1, contains the not equal to symbol, then the hypothesis test is called a two-tailed test. In a two-tailed test, each tail has a half of the p-value, everybody. So again, please pay attention. Half of the p-value is on the left. The other half of the p-value is on the right-hand side. So if you find the standardized test statistic and find the area to the left, you have to multiply by 2 to get the double of the area, and it's your p-value. Alternative hypothesis includes not equal to. So when you have not equal to, it means that you have a two-tailed test. Half of p-value is on the left, the other half is on the right. And we call it a two-tailed test. So what are the steps here? After stating the null and alternative hypotheses and specifying the level of significance, the next step in a hypothesis test is to obtain a random sample from the population and then calculate the sample statistic. Those can be X bar, P hat, or the sample variance, depending on the question. These test statistics are all corresponding to the parameter of the population that you're working with. If the population parameter is mean or mu, you're going to use X bar or sample mean. If the population parameter is P, proportion, you're going to use sample proportion. If the population parameter is the variance, you're going to use the sample variance. This sample statistic is called the test statistic. With the assumption that the null hypothesis is true, the test statistic is then converted into standardized test statistic z, t, or chi-squared. The standardized test statistic is used in making the decision about the null hypothesis. In the following table, we summarize this parameter test statistic and the standardized test statistic that we're going to discuss. So if the population parameter is mean or mu, test statistic is x bar, and standardized test statistic is z and t. If the population parameter is p, proportion, the test statistic is sample proportion, and the standardized test statistic is z. If the population parameter is the variance, you're going to use sample variance, which is your test statistic, and the standardized test statistic is chi-squared. How do we use a p-value to make a decision about hypothesis testing? Now you learn how to perform a hypothesis test for a mean mu, assuming the standard deviation sigma is known. When sigma is given, you can use a z-test for the mean. To use the z-test, you need to find a standardized value for z, which is sample mean minus hypothesized mean divided by the standard error that can be calculated as below. The z-test for a mean or mu is a statistical test for population mean. The test statistic is the sample mean, x bar, and the standardized test statistic is z, which is x bar, minus mu, divided by sigma over square root of n when these conditions are all met. The sample is random. At least one of the following is true. The population is normal, and n is more than or equals to 30. And please remember that sigma divided by square root of n is called standard error of the mean, and we denote it by sigma sub x bar. So now that we defined the standardized test statistic, we want to review the guidelines using a p-value or a z-test for a mean mu when sigma is given to you. First of all, verify that sigma is known, the sample is random, and either the population is normal or you have a large sample. State the null and alternative hypothesis and identify your claim. Specify the level of significance. Find the standardized test statistic, which is z equals to x bar minus mu divided by sigma over square root of n. Find the area that corresponds to z, and then find the p-value depending on the type of hypothesis test that you have. If it's a left tail test, p-value is area to the left. If it's a right tail test, the area on the right is the p-value. And if you have a two-tail test, you have to multiply 2 by the area to get the p-value. Then compare p-value and alpha. If p-value is less than or equals to alpha, you reject the null hypothesis. Otherwise, you fail to reject the null hypothesis. And then finally, interpret the decision in the context of the original claim. So let's take a look at a few examples. These are the guidelines that we're going to follow. In this question, in auto racing, a pit stop is where the racing vehicle stops for a new tire, fuel, repairs, and other mechanical adjustments. The efficiency of a pit crew that makes these adjustments can affect the outcome of a race. A pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. A random sample of 32 pit stop times has a sample mean of 12.9 seconds. Assume that the population standard deviation is 0.19 seconds. Is there enough evidence to support the claim when alpha is 1%? And the question asks us to use p-value. So one by one, we're going to investigate this hypothesis testing. First of all, sigma is given to us. Where is sigma? It says population standard deviation is 0.19 second. So that's how you have your standard deviation for the population. The sample is taken randomly, n is 32, which is large enough, and we want to use the z-test. The claim is that the mean pit stop time is less than 13 seconds. So the null and alternative hypothesis can be written this way. Because of the keyword less than, you have your alternative hypothesis. This is your claim. Less than, it says the average is less than 13 seconds. Its opposite, its complement says, no, it is more than or equals to 13 seconds. And we want to test this claim. The level of significance is given to us as 1% alpha. The standardized test statistic can be calculated using the formula z is equal to x bar minus mu divided by sigma over square root of n. X bar is the sample average, mean is the population average as mu, and sigma is population standard deviation, and n is 32. Let us use our calculator. We see that z is negative 2.98. So now that you have your z, you can calculate your p-value. The p-value is the area to the left side of your graph, which is about 0.0014. And since the p-value is less than alpha, you reject the null hypothesis. Remember that the p-value is the area to the left side of z. Z is negative 2.98. Let us take a look at our calculator and show how we can do this on the calculator. Let us pull up TI-84. I'm going to use the exact same version that you're using. It's a free version. So here, you're going to click on to find the area to the left side of negative 2.98. You can click on second, vars. And here, you can click on normal CDF. The lower bound, remember that this is the area to the left side of negative 2.98. So your lower bound is a negative number, like negative 10. Put a comma, and the upper bound is this number, negative 2.98. So negative 2.98. Put a comma. The mean must be 0 because it's a z-value. Put a comma with standard deviation of the z-value, which is 1. So if you enter, you see the area, or the p-value is 0.001. It's a very small number. Now you can also use your calculator to perform the hypothesis testing. You can go to stat and go to test and find So here we are not using the proportion everyone. We are not using two samples. It's not an interval. It's not about proportion. It's not about two samples. So you're going to select z-test. When you click on z-test, we don't have the actual data. So we can click on statistics. The population mean is 13 with standard deviation 0.19. The sample mean that we calculated is 12.9 and n is 32. When it says claim mu is less than 13 seconds, we have a left tail test. So you're going to select the left tail. Now click on enter. calculate. It do the calculation for you. As you can see, z, which is matching with negative 2.98 in our calculation, is the same as negative 2.977. If you round it, you get negative 2.98. The p-value is also calculated for you here as 0.001, 4, or 5. So basically matching what we calculated for our p-value. So let me show you again. Go to Stat, go to Test, and select Z-Test. You're going to enter the values in the stats. Mu, population mean is 13. Population mean is 13. Population standard deviation is 0.19. X bar is the sample mean, 12.9. Basically what we calculated in the question. And N, you have 32 in your sample. Since it's a left-tail test, you click on left-tailed and then go down here and do the calculation. If you click on draw, it basically graph it for you. The graph is located on the left-hand side. This is your p-value, which is very small. Next example for you. Hypothesis testing. In the second example, according to a study, the mean cost of bariatric or weight loss surgery is $21,500. You think this information given to you is incorrect. So as a statistician, as a data scientist, you randomly select 25 bariatric surgery patients and find that the mean cost for their surgery is, so the average cost for their surgery is $20,695,000. From past studies, the population standard deviation is given to you to be $2,250, and the population is normally distributed. Is there enough evidence to support your claim at 5% level of significance? So let's take a look at this step by step. We know sigma is given to us. Sigma, or population standard deviation, is $2,250. The sample is random and the population is normally distributed. You can use a z-test. The claim is the mean is different from $21,500. So since it's different from, this is your null hypothesis, saying that no, it is exactly $21,500. Alternative hypothesis and the claim are the same. So let's begin. The level of significance is given to us as 5%. The standardized test statistic can be calculated this way. Z is equal to X bar minus mean divided by sigma over square root of n, which can be written as 20,695 minus the population mean, which is $21,500, over sigma over square root of n, which is square root of 25. It happens that the z-value is negative 1.79. The question is, what is the p-value? So now that we have our z, we can calculate the p-value. P-value is 2 times 0.0367 or 0.0734. So p-value is going to be the multiplication of 2 by one of these areas, or adding these two areas together. Because you have a two-tail test, it means that half of the p-value is on the left, the other half is on the right. But please note that p-value is more than 5%. So since p-value is more than 5%, we're going to say, hey, we fail to reject the null hypothesis, or we are supporting the null hypothesis. Now let us take a look at our calculator and see what do we have here using our calculator. It's important to feel comfortable using a calculator when it comes to exams and homework. Let me share the screen with you all. So first of all, to find this number 0.0367, you can go to second, vars, and click on normal CDF. Let me just erase everything. Second plus, I'm going to reset everything. Now I'm going to go to second, vars, and normal CDF. For my normal CDF, what I have, I'm going to enter the lower bound. Again, please pay attention. For the lower bound, you're going to use a very small number like -10. Put comma. The upper bound stops at -1.79, -1.79, comma. Mean of the z distribution is 0, comma, with standard deviation of 1. So that's how you can get the value of negative point. Make sure you can see it. Is this area, which is 0.0367. This is the area, just half of the area. This is half of the area. So to get the p-value, you're going to multiply it by 2. Now let me show you how to use your calculator to basically run this test. Go to Stat, go to Tests, and use z-test. Since we don't have the actual data, we're going to use the statistics. The population mean is 21,500. Standard deviation of the population is 2,250. The sample mean that we calculated is 2,695. And the number of people in our sample is 25. And it's a two-tailed test. So we're going to select the very first one and then go to calculate. When you go to calculate, this is what we see. Z, or the standardized test statistic, is -1.79. The p-value is 0.0734, or which is very close, 0.0736. So these numbers are very close. We're basically caring about the 7%. And then, since it's just 7%, it's more than 5%. So we support the null hypothesis. Again, if you go to Stat and go to Test, you can basically visualize this by clicking on Draw. And here you see you have a two-tailed test. Half of the p-value is on the left, the other half is on the right, and this is your p-value about 7%, which match with what we got algebraically.